Welcome to Spring LIB.
So the speed parameter that we have for part A, beta, is V over C. Then we can find V over C by setting a delta x dash is equal to 0 and writing the Lorentz transformation equation, which will be 0 is equal to gamma times delta x minus V times delta t. Now delta x we have is x2 minus x1, x1. So this will be x1. So this we have is a minus, by plugging in x2 and x1, we have a minus 720 meter. If we plug in this delta x here in this equation, then we can plug in the delta t, and then we can solve for a beta. The beta we get here is 0.480. Part B. So as we can see here, a delta x is a minus 720 meters. So this implies that S dash. This implies that we have the S dash frame must be moving in opposite direction of x. So it should be moving in. So let me just. So it should be moving in a negative x direction, negative x-axis. So I will write negative x-axis. In part C, so our delta t, we can write in using a Lorentz transformation, the gamma into delta t minus v delta x over speed of light square. Then we can plug those values and we get this value to be positive. So this implies that the big flush went first. So the big flash went first and the smaller one came later. So the smaller one came later and the big one came first. In part D, so the big flash, so I will write the big flash here. Big flash first. Okay. In part D, we are asked to find the exact value of a delta t. As we did previously here in C part, we can plug those values, a value of a gamma delta t, and then we can get the delta t which will be 4.39 times 10 to the power minus 6 seconds, or 4.39 microseconds. End of the problem. Thank you for